Okay, so let's take a brief look at why we're talking about projections here. You are of course familiar with what projections are, at least in real life. Maybe some of you have been to the White Nights in Melbourne. If you don't know about them, it's a fantastic event where the whole city is open for the whole night from the evening till 6 o'clock, 10 o'clock in the morning, I don't know. There are lots of arts expos, all the famous buildings are open, and there are lots of light installations and projections around the city. So for example, here you see a projection on the front of the State Library, I believe. So how does such a projection actually work or happen? Let's take a smaller one here. This is another picture from the White Nights where there was the seascape of Port Phillip projected onto the inside of the State Library. So on the simplest level, how does such a projection happen? Well, we've got a light source somewhere. My drawing isn't particularly good, but let's assume this is lamp, give me the benefit of the doubt. And you've got an object somewhere. Let's say this person here. So the light rays go out from the light source. And at some point they hit the surface onto which you project, a silver screen or that building, for example. And so that person is going to appear much bigger there because that's how the light rays run. Now let's think about what happens if I move that person further over here, or equivalently I move the light source further away. So let's start again. I've got that light source here. Now I have the person, let's say, over here. I will assume that's roughly the same size, right? So now the rays run sort of like this. And the person is still bigger than in real life in the projection, but not much more so. Right? So let's think about what happens if I move that person even further away, or alternatively, if I move that light source further away to the other side. Let's move that all the way out to infinity. Where do you think the rays run, and what do you think that object, that person on the projection screen will look like then? Well, if we move the light source all the way out here to infinity, we'll still have the person here. This bundle of rays, it was like that in the beginning, and then a bit more like that, will ultimately become flat, or the rays will be parallel. And when that happens, of course, the person on the projection image will have the same size as the person in real life. Okay, and so a projection is nothing but taking these points here in real life and mapping them mathematically to a point on the projection screen. Now you don't have to bear my drawings any longer, so let's move on. Okay, let's try to capture this mathematically. Again, like before, we've got the person over here, and we've got the rays here. Now let's pick one point on that person. Let's say here, the foot. And that has a coordinate. Let's assume we've got a two-dimensional space here mathematically. We ignore the third dimension for now. So that dimension here is x, and that dimension here is y. And the projection surface simply runs parallel to x. So let's say the y coordinate of the projection surface is 0. So what happens here, this point here, the foot, is of course at some coordinate x, y. Now the x coordinate doesn't change because the ray is parallel, and the y coordinate here just becomes the one of the projection surface, which is 0. So in other words, the position of the foot here will be x, comma 0, or simply x. And the same thing would of course happen in 3D, only in 3D we would only be eliminating one coordinate. If we also had z-axis here, then we would be projecting a point at x, y, z to xz in this case. Or we could of course eliminate another coordinate, but that's really all that happens, right? So to summarize, if we take a point in 2D which is characterized by its x and y coordinate, and we project that onto the x-axis, then the y coordinate disappears and we're ending up with x, 0, equivalently just x as the coordinate. And the same thing in 3D, if we take x, y, z as 3 coordinates and we project that onto, what now? We can't project just onto one, we have to project on a plane. We're only eliminating one coordinate, so let's say we're projecting on x, z, then we're losing the y coordinate and we end up with a point which is x, 0, z, or simply xz. And that's really all there is to those simple projections that we want to use now.